Alright guys, welcome to my video here on static routing. This is Santec IT Solutions here, and this is my CCNA playlist series. In this video, I'm simply going to just be showing you how to run some static routes across three different routers. There's three different LANs attached to each router, and it's crossing over two different WAN links. So you can see the 192.168 networks are the WAN links, and the 172.16 IP addresses are the LANs. So first I'm going to start with the Seattle router, and there's three different type of static routes you can configure on these routers. You can do a source IP to destination IP, and you can do a source IP to egress interface, and then there's a default static route. So I'm going to start with showing you the source to destination IP. I've already got my interfaces configured, so I'm going to show you the routing table. That's a show IP route command. And in my routing table, you're going to see I have two routes, and they're labeled with a letter C. And as you see up there in the code, C stands for connected. So connected routes are already set because I put in just by simply configuring the interfaces for those and it sets up a connected route, so to speak. It detects them. So I'm going to put in a command IP route 172.168.20.0. You can see that's my neighbor LAN there. That's my remote LAN, so to speak. That's has a mask /24. That's a standard /C mask, and I'm going to give it a source IP address. So this is saying any route that falls into this subnet 172.16.20.0 with this mask is going to point to this IP address 192.168.10.2, which is my egress port on the Chicago WAN link there. So I'm going to do the same thing for the .30 LAN network, which is over in New York. So I did that really fast. As you can see, I just switched the one. All I had to do was switch and it's pointing to the same egress port. I don't have to point it to anywhere but just that same egress port, which is actually going to act as the ingress port for any traffic going to New York, is actually going to route to Chicago first. So then I set up the 192.168.20 WAN link in case I need to make any connections to the routers on those ports. So now you can see I'm running a show IP route again, and there's some new entries here. This is the original command I ran, and now you can see there's three new entries for our static routes, labeled appropriately with the letter S for static. And those are now telling you, for example, there 192.168.20.0 is via those routes are going to come from 192.168.10.2. So now I'm going to go over to our Chicago router, and I have to set up some static routes here. This type of route, though, I'm going to demonstrate is going to be from a source IP subnet or LAN, whatever you want to call it. You're basically your source IP address pool to egress ports. So I'm going to use the ports this time as our outgoing information. And you see I already set up the IP addresses. I put them on the interfaces we're using. We're using Fast Ethernet 00 and the serial interface 2/0 and 2/1. The IP routing table right now has three connected routes because I have three connected interfaces that are active and working. So I'm going to go ahead and ping and demonstrate that if I can't reach the Seattle LAN right now, the 172.16.10 is in Seattle. It is just timing out. There's nothing going on there. I'm not making any connection. And let me also demonstrate that I can't ping, or actually I should be able to ping that because it's connected. So the 192.168.10.1 network, that I'm connected from the .2 interface, so it detects that. It's able to route the packets there. And the same thing on the New York side of things. I'm able to ping the New York outgoing WAN link port, but I can't get into the LAN. So you see here I'm doing the .30 LAN subnet now, and I'm getting no success. And the same thing was happening in Seattle. I couldn't get into the LANs, so that's because it doesn't. Those routers don't have a route for that. So it receives that packet once I've done, and it doesn't know where to send it. Believe it or not, even though it's connected to it, it still does not have a route for that information. In that case, I'd only be able to ping those LANs from the New York or Seattle router itself. So if I was in Seattle router, I'd be able to ping the 172.16.10 network, but from a remote device, it won't work. So I'm going to set up our 3 IP routes. So you already did the IP route to the Seattle LAN, and I'm sending it out serial 20 for that, and I'm sending out serial 21 for the .30 New York LAN. And now you can see my routing table has changed quite a bit. So I've got static routes for my LANs, and I'm going to save the configuration. And I don't want to test pinging yet. I want to configure my New York router first. So I'm going into the New York router, and this router, I'm going to show you the third type of static route, and that's a default static route. So that's all I'm going to put on this router, and it should work just fine. So the reason I couldn't do that on the Chicago router is because it has 2 different egress ports going 2 different directions. So if I set one default route, it would just send everything. It would be a mess, and the packets would get lost. So I'm going to show you this. Show you the routing table. Only my connected routes are there. So now here's the default static route. IP route 0.0.0.0 with a default mask of 0.0.0.0. This pretty much stands for IP route any.any, and it's going out serial 2/0, which is the New York WAN link port. And so once I set the default, you're going to see now an S with an asterisk, which indicates that as the default static route on this router. So now I've got my 3 routers set up with the routing information they need. I'm going to start pinging the different ports and see what we get. So now I'm pinging Chicago's LAN, and I have success. Now I'm pinging this the host inside the Chicago LAN, and the first pass some packets got lost, but on your second attempt everything goes through just fine. That's normal. The first time you connect, sometimes there's a few packets that get lost. It's only bad when none of the packets make it through, and then you have to troubleshoot. So for now we've got everything working from Seattle over to Chicago's LAN, and I'm just going to try pinging out to New York now. So you see I changed the IP, and that's working to the default gateway over there. And let's see if we can ping the host inside of New York, the actual computer or server there that I'm using. And we got packets there, everything looks fine. So now I'm going to show you a trace route. And I'm just going to trace a packet all the way to the New York host. So we see our first hop was the .10.2, which is our Chicago router, and the next hop is the .20.1 port, which is our New York router. So you can see it hopped from Seattle.1 to .2, which is the Chicago port, and then for our next hop it goes from 20.1, basically from Chicago over to the New York port on .20.1, and then our destination, which is the host, which is 172.16.30.2. So now I'm going to go ahead and show our routing table again. Let's see what we've got. And you can see now we've got all the routes we need for this little network setup. Everything is in the table, and I just want to show you the MAC address table, or the ARP table here. It's not really, it's called show ARP command, and right now we only have this one ARP entry, which is for the default gateway side, the LAN gateway side of the router. But I'm going to go into the actual host, and I'm going to show you some more basically from the perspective of the host end of it, you know, the actual computer itself. So if I ping, and right now it's not working, so I'm not able to reach New York, and I'm saying, well, why not? How come I can't ping that? And the reason for this is actually, it's quite interesting because you'll see here those look like computers in GNS3, but these are actually Cisco routers that I'm using in place of a host. Don't actually have a real virtualized host that I could run, so I'm just using a router in place of that. And I change the symbol, make it look like a little computer. So this is actually a router, and this router is set up with is also acting like a router. So it doesn't have a routing, it needs a route to know where to go. So if I show you the IP routing table, all it knows right now is the connected interface, which is the LAN that it's in. It doesn't anything outside of that, and it's not going to know where to send it. It's going to say, oh, I don't know where that goes. So if I put in a static default route on this device, and I just pointed out the only interface that's there, which is the fast Ethernet 0 interface, it will send all traffic out there, and the router, it'll hit the router, and the Seattle router will know automatically what to do with it, because we had set up, if you saw before, the CL router has all the routes in its table that it needs for those subnet, those IP subnets that we're trying to reach. So now let me try it again. And we should have success this time. It might stall up on us a little bit since Seattle's far away. No, I mean, just kidding. New York is, well, there we go. We've got 5 out of 5. So now I can show you the ARP table, and you can see that we have an entry for the MAC address of, it's not actually the real MAC address of that device, but the MAC address that we need to send the IP packet to, for it to route to that particular device. So in this case, it would be, I believe, that MAC address is most likely the Chicago interface, the .2 interface of the Chicago WAN link. But let's ping a few more devices on this network. And now we're able to ping everybody. So I'm able to ping the LAN in Chicago. I can ping the LAN in New York, and of course I have connectivity to everything in Seattle from this host. So I'm going to jump over to the New York host, and I'm just going to show the routing table again, so you guys get the point of view from the New York side. And this one just has a default route, remember that, so there isn't any specific static entries, but it should still work. And there we go, I pinged the Seattle side, the .10 network, and I want to show you the ARP table. And now we'll go into the Chicago host just to also verify everything's working on that side. Alright guys, thanks for watching my video, and in conclusion, basically we set up the 3 different types of static routes. You had your IP source to IP destination, you had IP source to interface, and the default static route. So I hope this is helpful, and thanks for watching.